Dewaxing also, as I said, there was a separator-based process. Then we have a lot of issues about effluent, a lot of issues of water uses, non-consistency of the quality, like 0 degree 5.5 hours. These are the lot of issues we are facing. Then came WinWax can process up to 500 ppm. Now this problem was that this is what we call as a lipofrac process first. Second is a dry fractionation, dry winterization. There, earlier, whatever horizontal filters were available, they can take up to 1000 ppm of wax. Anything more than you have to redo the dewaxing. That was a drawback. So, overcome this drawback, there are two types of filters introduced in the market. One is WinWax, it can take up to 5000 ppm wax, and also RBO up to 3%. It is every filter is 200 square meter filter, and depending on the application, it can give the filtration. And then this Miura super filter. They're also working fine. The holding volume for the WinWax is more, holding volume for super filter is. So low capacity plants and all that, super filter is better utilized. And then super filter is something like working at around 100 around the quarter. WinWax is latest development. It is just introduced. So WinWax is around 35 to 36 operation. These are just brief economics. Because when we talk about economics, economy comes. If you see that hierarchy of this one, economy comes. So if we simply say that this does not need a filter aid. Earlier, without filter aid, dewaxing was not possible. We have to use a filter aid. And when the waxes are separated, that waxes with a filter aid was useless. It is no market for that. So here you can see 200 and filter aid, paint filter aid is 4 kilo, filter aid is 28 rupees kilo. Wax ppm was 0.2%, that is 2000 ppm. And oil in wax is 80%. Oil in filter aid is 65. So it is a misnomer. If you see here, it says the oil and filter aid is 65%. That means it should be economical. But that is not the case. Even though it is showing 80% here, it's still economical. How it is? You can see here, wax generation 10 kilo, but you are getting the value for that. So for 200 tons, your saving is approximately 134 lakhs per year. And that is the beauty of this. With that, we come to the next stage. As I said, earlier the palm oil fractionation was done vessel-based. That is what we call the batch type. Still today it is preferred. So sometimes it is said that recipe adjustment or recipe required for batch is something like critical. Like for example, if we take the example of Hindustan Lever, whatever happens, they believe in batch process. God knows why. But then that is the case, I would say mindset. Then here, we have, there is an introduction of continuous icon, what you call the continuous fractionation process. And it is something like a 3G mobilizer. Okay, I'll not go into that detail because there is a slight video is there. But major advantage of this technology is that earlier, if you see, yield was 78%, was supposed to be good. Then it has gone to 81%. Now today, it is almost 84 plus minus 2 it is getting. Now, a lot of people say, what is great in that? This is the formula, and on the basis of this, it is happening. What is the great in that? But then, your movement, crystal formation and all that is additional 2%. Because high pressure membrane filter can give yield something like half to 1%. But the technology, the real crystal formation can give you. Otherwise, this is not possible to get up to yield 84. And that's how that stearin is coming to 16%. And this is how, this is very important. Steam consumption. Because in palm oil, it is said that palm oil crystals have a strong memory. Once the crystal is formed, they have a memory. They will behave as per the memory. Until you remelt them, they will not lose that memory. So again, we have to cool it, heat it, and again cool it. That's all. But here, the adjustment in such a way, okay, this is something just quickly shown that how it is done. There, heating and cooling, everything, heat recovery is taking place here. And then you can see the sink consumption is 27 kilo per ton. And power has also come down. Because the capacity, suppose we are doing that residence time required for case of vessel base or batch type of this one, 8 to 8.5 hours is required for the fractionation. But that is not the case here. It is 4.5 to 5 hours. That's how you reduce the number of crystallizers, you reduce the number of the space required for that. I think nobody is doing this in India at least, but it was introduced some 4 years ago. That is stirring refractionation. What is mobilizer? See, mobilizer is having that movement, coil movement inside, and heaviest viscosity material it can move. It cannot be possible in the batch type of crystallizers. So if you see that PMF, palm mid fraction, can be produced here, and what are the yields? It is actually 8 to 10 plants are working in India, and that is a very good additional benefit. Otherwise, stirring either is going to oleochemical or it is going to some other use. But here it can be, because this PMF and all that can be utilized in some of the cocoa butter and cocoa butter equivalent substitutes. Now coming to RBO, rice band dewaxing. Earlier, rice band dewaxing was a big challenge because 16-degree cloud point was allowed as such. But now the health consciousness is there. So people want exactly the same quality what they are looking for sunflower, which is not possible traditionally as of now. We have done a lot of trials, a lot of field trials, plant trials and all that. So this is, the new application has come. I think it is a newly published. Before this conference, it was not discussed anywhere. So this is newly published here. So here you can see that after RBO dewaxing, there are two types of dewaxing we can do. A lot of people do just dewaxing and don't do the winterization. After dewaxing, what happens, if you don't do the winterization, there is called a 2% tristerin are there in rice bran, which is not removed in that dewaxing. But a cold, if you want to have that better cold taste, it is very difficult to get that. So government has given 16-degree cloud point, but that is not correct. That is not applicable now. Now 10-degree cloud point is possible by dewaxing, simple dewaxing. But here, when you do the dewaxing, now here, there is a mobilizer. Mobilizer, again, I told you that it can deal with highly viscous material. That means when rice bran we cool down to certain temperature, it has become very viscous, which is not possible in other cases because that viscous material cannot be filtered. Here is a membrane filter plus mobilizer. The first step is that you can get a dewax oil of 0.4 degree, cloud point of 4 degrees centigrade. Dewax oil yield is 95 to 97%. Now winterization. Suppose we do dewaxing first and winterization afterwards. This is the results. Winterized oil cold test is 0 degree, 5.5 hours. That's exactly what we are giving for sunflower today. And that is what is required today. Because sunflower, as I explained to you, that rice bran oil, 5% consumption is 5. Because a lot of people are now promoting rice bran. They're consuming rice bran, and really good. If you do the physical refining, only original is possible. If you do chemical refining, original is gone. In Thailand, still they do the chemical refining. So it becomes easy for dewaxing, but in physical refining, the crystal formation and all that is a typical aspect. Because crystal formation in rice bran and crystal formation in palm oil are totally two different areas or two different aspects. Now, a lot of people think that why we should do a separate dewaxing and separate winterization. Can it be done combined? So yes, there is a solution. We can do combined also. So combined dewaxing and winterization will give you winterized oil cold test of 5.5 hours and winterized oil yields 90%. If you do dewaxing, winterization yield will be lower than 90%, but here you can get it. And of course, yesterday we had discussed the Qualistock new deodorizer is introduced a few years back. There are a lot of plants are working on that. And here you can see that there is no generation splash oil. The stripper section integrated for palm oil. Steeping steam has come down. Earlier it was 8, 10, 12. Now there is come down. So economically it is been. And the important thing that earlier PFAD, palm fatty acid distillate, were in the range of 86, 87, 88. Now there is a special technologies introduced here which gives you FFA of PFAD 93. Means FFA of PFAD 93 means you get better yield. And again, this is the integrated stripper which can give the flexibility, as I said in the beginning, whether you want to keep tocopherol removal or you want to keep tocopherol content in this one. Because tocopherol is going to be a major aspect in coming years, which we cover in the next session. And you will understand how that is going to be very important, vitamin E and all that, how it's going to change the scenario in coming years. This is the overall look. And finally, the new deodorizer just arrived, the newborn baby, is low trans deodorization. Thank you so much.
Any question to Kamlesh?
No question is bad scenario.
Yeah, good morning. Here is a question for you, Kamlesh. Is Sai here?
Okay.
Yeah, you have talked about this Nano. And is it, why it should not work for SF? Why is that for the first time SF and all? Even about 4 or 5 years back, I also put this question to your team.
But that one, it was on soya bean.
Soya, yeah, if it works for soya, it should also work for sunflower. It is only
that is the logic there, because our people in Europe, they are so particular. If it is performance is taken on soybean, okay, if it is in sunflower oil, they will be thinking twice. So we said, okay, we do that sunflower oil dewaxing or sunflower nano first time in India, and we have done it. You are right, with the soybean or sunflower, is not both are almost the same quality of.
And I would have told you that I would even mention that, even feel that, depending on the parameters and then the quality of the oils, if it works for sunflower, it may not work for soya. That can be a question. But if it works for soya, it should work for sunflower.
No, I think it's work almost 40-50%. I think Dr. Wim is going to cover that aspect. You will get the latest scenario of the Nano, what is happening.
So do you recommend for us to go ahead with the Nano for our biggest plant, largest plant?
I think that question will be best answered by the real expert or my next speaker, Dr. Wim.
The second one is about this
RBO,
I mean rice bran oil. So most of the rice bran oils are being contaminated with, mixed with glycerolysis product of oils. And it is, even today also, nobody can say that it's not harmful. It is harmful. And even FSSA also is going to release their legislation now, very, very soon. And that is the one issue in front of our industry. I wanted to share with you. And thank you, and a very nice presentation.
Thank you so much.
As expected. Thank you.
Thank you so much.
Good morning, sir.
Just one quick, easy question.
Point it out, because I'm not able to see, because it's important to
This
see
side.
the face first. Okay.
Yeah.
Shailesh. Okay.
Yeah, Shailesh. About winterizations, you said Winwax is used. And that, but what is the quality on the Winwax? It is not given, like, so how much wax ppm? Because earlier slide we have seen that wax ppm, cold test, and 5 up to 25 bpm is going to be, so what is the Winwax?
In
wax
Winwax, we have done that analysis. You get some in the range of 50 to 60 ppm of waxes after doing wax. Because another thing is, remember, this is not only filter, we decide the quality of oil. It is the crystallization also. So both together, it is not a filter only. Filter will filter what has been fed to it. For what is feeding to filter has to be prepared first in the crystallizer. So crystallization, your timings and your crystallization cycle and all that is important. But as compared to this one, we are getting 50 to 60 ppm of waxes.
So it will meet the next generations like requirement of the waxes?
Yeah, that exactly I have explained in case of rice bran, because we have tried membrane filter also, that where we can do that. But as of now, there is no results on membrane filter.
Thank you.
Thank you.
Alam, that's an easy question for you. We know about 3-MCPD and how much work they have done
Enough
and all
is
these
enough.
things. So, when I was growing up here, we were using trans fatty acid 50% in our diet. So I'm still alive. So I don't know how big of a deal of 3-MCPD, but it is. Whoever is going to buy now palm oil, they have to have this analysis and done. I'm talking about, as you mentioned, the precursors is HCl, hydrochloric acid. How about not using those activated clay? Just go with the natural clay, and with these developments of Dismith or Crown, with this fancy deodorizer at low temperature, high vacuum, minimize that formation. I know the color will not be matched, but has anybody done that or approached that, that way of processing, not using activated clay, just by natural clay? In the processing world, like you guys.
Yeah, as I explained that there is not a solution as of now, permanent solution, because a lot of people are saying, in the morning also we are discussing, that chemical refining cannot be economical. So if you see that what is optimize physical refining aspect what I have presented, that is, I kept the India in the perspective, what should be done in India. Internationally, Europe and all that people are doing a lot of other things. But if you use the neutral bleaching earth, that is a better on controlling the MCPD. If you use activated bleaching earth, we don't know, because suppose activated bleaching earth is done activation by sulfuric acid, which is again a very old traditional thing. It will not have the impact on MCPD increase. But if you do the acid activation by HCl, hydrochloric, then it will have the impact. That exactly I have presented there.
So I have one question for you, Kamlesh. What you have covered is the lot of evaluation in the processing parameters, technologies. How do you think that how it is going to help for, because the people are talking about Industry 4.0 now, means the use of automation, robotics, machine learning, and artificial intelligence. So how do you think maybe next 10 years, the equipment, what the technology supplier like this Metal Alpha Level or whosoever are there going to cope up with this, especially for India?
This is somewhat imaginary for me, because when I say today and tomorrow, it is a process of continuous improvement, I can say that. Because what we have seen in 1996 or 1999 is totally different today. The new challenges are coming every day. We never knew that MCPD was a challenge when we were processing earlier. A similar way, there are a lot of other challenges are coming. So I think every supplier, they're having their own R&D and they're doing. So I think in next 10 years, you will see a total different technology. But people are gearing, challenges are there.
Okay, thank you.
Sir, question from you. This is Prasad from Parak Food.
Prasad.
Yeah. Sir, you mentioned that there is a wax, when we do wind wax filters, there's a 80% oil in it, and the 20.2% is wax. And is there any mechanism to take out the oil from the wax? So 80% wax can be recovered continuously?
Yeah, it is there. See, what happened, here what you are getting is a pure wax.
Yes.
Okay? If you sell this wax, you get 24 rupees a kilo or 28 rupees a kilo. Okay? Either you sell the wax as such or recover the oil and sell it. If you recover the oil and sell it, you get a better price. But for that, there is a hydraulic. Today, as of now, there is no solvent involved. There is a hydraulic press. So where we have to just, okay, it is traditional and this one. So you have to put in the gunny bags and put in hydraulic press and remove. After doing that also, your wax content in the wax will not come down below 45%.
Yes. So is there any continuous process like that?
No, that unfortunately has not been developed, because people say that anyway wax has been sold like that. The major concern was filter aid in wax, which is removed now. So that is the first step. A second step will automatically come. As I said, there is a continuous improvement. Issues are coming. We are approaching the issues and solutions are coming.
Right, sir. Thanks.
Okay, so if there are more questions, you can take it during the break. Thank you, Kamlesh. Thank you for highlighting all this. Okay, so let us invite the another
Sir, I
speaker.
would like to request you. Thank you, sir, for your insightful session. I would request our chairperson, Mr. Bhaskar Khande, to felicitate our esteemed speaker, Mr. Kamlesh Kapadia, with a memento.
So, I invite another speaker, Dr. Wim. Dr. Wim graduated in 1988 as engineer in food technology from the Faculty of Applied Biological Science at the University of Ghent, Belgium. He obtained PhD degree in the same university in 1998 and with a study of effect of physical refining on selected minor components in vegetable oil. He worked as a research assistant in the Department of Food Technology and Nutrition. Later he joined Extraction Desmet, where he worked as an R&D project leader from 2000 as an R&D manager. Today he is working as a senior R&D manager coordinating the R&D activities of Desmet Ballestra Group in the area of oil seeds and biomass preparation and crushing, oil refining and modifications, oleochemical processes, including biodiesel production. He is co-author of more than 55 scientific papers, known as presenter at international conferences and workshops. He is a member of the American Oil Chemist Society since 1996, and since 2009, also as a co-chairman of the processing division of Euro Federal Lipid. In this position, he served as a member of the scientific committee of the Euro Federal Lipid conferences in Greece, Rotterdam, Antalya, Ghent, and Uppsala. Okay, so please welcome Dr. Wim. Dr. Wim, thank you.
Thank you, Mr. Chairman, for this very extensive introduction. At the beginning of my talk, I also would like to congratulate actually the conference organizers for setting up this very nice event. It was really a pleasure for me to be here and to give a talk in the coming half an hour on nano-neutralization. I remember that I was here back in 2012, I think, so this is almost, or this is 7 years ago. And then I also talked about nano-neutralization, and at that moment it was really, we were at the beginning. We did not really know what was the process going to give. We had already some first plans, and we did a lot of promising tests. Today I'm here to talk about a process that is really industrial proven and that we can consider really as a next or part of the next generation chemical refining process. Oh, this is a slide that we've seen already. As a first slide, I would like to give a bit the context of where oil processors have to work in today. So you see that it's a very complex situation with, as was mentioned already a few times before, a growing consumer awareness. So there is the social media. Consumers are much more closer to the product. They want to know what they consume. At the same time, there is a stricter legislation, legislation that is not only dealing with things like trans fatty acids, but also 3-MCPD and glycidyl esters may come in the picture. And there is also a difficult market situation. Margins, profit margins are low, so there is a need really for cost-efficient and sustainable processes that can give at the same time also a high-quality food oil. And in practice, this means that processors have to adopt refining processes that guarantee at the same time a very good quality, low level or absence of contaminants, but also that they do it at the highest possible efficiency with the least possible side streams. Now, for that, there are basically two options. So there is either the chemical route or the physical route. And we had just before the session started already a discussion about what is now the best refining process, whether it is chemical or physical. Well, honestly, there is no real answer on that question. I mean, it depends on which oil you want to process, which are the quality characteristics actually of the crude oil. And basically what we see today is that most of the soft oils like soybean oil, sunflower oil, but also corn oil are still being chemically refined, while for the tropical oils like palm oil, coconut oil, also palm kernel oil, these oils are mostly physically refined. And okay, there is a kind of trend where you see that people or processors are moving more in the direction of physical refining. In Europe, for instance, we see that rapeseed oil is more being physically refined now than it was 10 years ago. But still, we see that, okay, the shift from chemical to physical refining did not happen as we expected maybe 10, 20 years ago. I remember when I started in the company, then we talked already about physical refining and that was going to be the refining process of the future. Today we see that although the driving force to go to physical refining is there, that chemical refining is still the most applied refining process, and that is because, of course, it is the most forgiving process and that it gives you overall maybe the best quality. But we know that it has some drawbacks. So there are the high neutral oil losses in the soap stock. There is also the difficult valorization of the acid oil. We are looking here or there into technical applications. And last but not least, of course, there is also the difficult and also the expensive wastewater treatment, which makes it not so attractive in the end, but still it is the most applied process. And what we receive as feedback from the market is that there is a continuous process or a continuous demand actually for an improved chemical refining process. And that is also the reason why over the years a lot of work has been done to try to improve the chemical refining process. And first of all, processors were looking into options for better soap stock valorization. We were trying to use, instead of sodium hydroxide, other alkaline components for the neutralization of the free fatty acids like calcium oxide or potassium hydroxide. And the reason was actually because, well, the resulting soaps should have a higher or a better valorization. Unfortunately, now, today, the conclusion is that this is not the case. These processes are not applied industrially because, well, operating cost was too high, the results were not consistent, or in the end, the valorization of the soaps was not as expected. Well, recently, we are working on an improved soap stock splitting process, which is, you can say, also in the introduction phase. It is a so-called soap carbonate technology, where we do a soap stock splitting in absence of sulfuric acid. So we use actually CO2 at high pressure after a thermal hydrolysis, and that gives us a very good and a quality of acid oil. We are now well, starting up or commissioning the first industrial plant in China together with Inventure, who patented this process. And well, within a few months from now, I hope to have the first results and to communicate to you about that. Other process improvements are related to actually the washing step. For instance, we see more and more that this washing step is replaced by an adsorption step, a silica post-treatment to remove the remaining impurities like residual phospholipids and also soaps that are still present after the first soap centrifuge. And another thing is that we see is that, well, we use more powerful mixing techniques. And the reason there is, of course, to reduce the consumption of the chemicals. And we have seen over the years an evolution from static mixers to ultra-high shear mixers. These ultra-high shear mixers, of course, have a high energy consumption, but this is then compensated, or by far compensated, by the lower chemicals consumption. And then the question came up, can we further improve this efficiency? And that is actually how we came to hydrodynamic cavitation as one alternative process. And when processors hear cavitation, they are always a bit scared because cavitation is mostly linked with pumps that are not working well. Here we talk about something totally different. We talk about hydrodynamic cavitation. And hydrodynamic cavitation is actually the effect that is generated when you pass a liquid or a mix of liquid through a constricted channel. It can be a nozzle, it can be a Venturi system at a specific velocity, at a specific pressure. And by doing that, you generate actually bubbles. There is a vaporization, a generation, a collapse of bubbles, and that effect is actually what we call hydrodynamic cavitation. And if you see what is really happening then when hydrodynamic cavitation occurs, well, there is a very high energy density. You have locally also very high temperatures and pressures for a short time, but overall the ambient conditions remain the same. And in the oil, you see a generation of high turbulence, high shear forces, so a very good mixing effect. At the same time, there are also some, well, you can say physical chemical effects, like fragmenting of molecules and also full disruption of micelles. Hydrodynamic cavitation, well, a lot has been published already about it, and what we can say is that it is much more energy efficient than acoustic cavitation. Acoustic cavitation was actually the first cavitation process that was studied for degumming of oils and fats, but it never was industrially applied because the energy